Electric power changes acceleration. The Rimac Nevera produces nearly 1,900 horsepower using 4 independent electric motors, one at each wheel. That configuration allows precise torque control beyond what combustion drivetrains can achieve. But electric performance introduces different limits. Unlike a combustion engine, which builds power through rising RPM and gear shifts, electric motors deliver maximum torque instantly. From 0 RPM, torque is available. That instant torque produces extreme acceleration. The Nevera can launch from 0 to 60 miles per hour in under 2 seconds. That kind of acceleration is not limited by engine response time. It is limited by traction. Four motors allow advanced torque vectoring. Each wheel receives independent power control, allowing the car to adjust torque dynamically during acceleration and cornering. This improves stability and grip. But torque vectoring does not eliminate physics. Tire friction still defines maximum usable force. The contact patch between rubber and asphalt remains finite. Too much torque and the tire slips. Electric motors do not wait for boost pressure. They do not spool. They deliver force instantly. Managing that force becomes a software challenge layered on top of mechanical grip. Then there is weight. The Nevera's battery pack provides the energy required for high power output. But batteries are heavy. Energy density remains a core limitation of electric performance vehicles. The battery mass lowers center of gravity, which improves stability, but it increases total vehicle weight. Increased weight increases inertia. That affects braking distance and cornering dynamics. High-speed electric performance is a balance between energy storage and mass control. And then there is heat. High power output generates significant thermal load. Electric motors, inverters, and battery cells all produce heat under sustained performance. If temperature rises beyond operating thresholds, power must be reduced to protect components. Thermal management becomes critical. Liquid cooling systems circulate through battery modules and motor assemblies. Heat exchangers dissipate energy. Under extreme use, repeated launches or track sessions, cooling capacity defines performance consistency. Electric vehicles do not suffer from turbo lag. They suffer from thermal saturation. Sustained high output drains battery reserves rapidly. High current draw stresses internal cells. Over time, repeated high discharge cycles can affect longevity. Peak output is achievable. Maintaining peak output is the challenge. Regenerative braking adds another layer. When decelerating, the motors act as generators, recovering energy and feeding it back into the battery. This improves efficiency, but under aggressive driving, friction brakes must still handle significant thermal load. At nearly 2,000 horsepower, deceleration forces are enormous. Aerodynamics also matter. While the Nevera focuses on acceleration and high-speed capability, aerodynamic drag still increases with velocity. Electric torque can overcome resistance quickly, but energy consumption rises steeply at higher speeds. Unlike combustion hypercars chasing top speed, electric hypercars balance acceleration with battery efficiency. Push, sustained high speed, and range drops rapidly. The ceiling is defined not by mechanical explosion risk, but by energy depletion and thermal management. Electric performance rewrites the experience. It removes delay. It compresses acceleration into immediate force. It shifts complexity from pistons and crankshafts to power electronics and software control, but it does not remove constraint. Battery weight limits agility. Heat limits sustained output. Tire grip limits usable torque. The Rimac Nevera demonstrates what happens when nearly 2,000 horsepower is delivered without combustion. It is not about revving higher, it is about controlling instant force. And at that level, the limit is not how fast the motor spins, it is how much energy you can store, cool, and transfer to the ground before physics pushes back. Because electric speed is not infinite, it is stored.